In lesson 12.3, you will analyze geometric sequences and series. In a geometric sequence, which is another special sequence, the ratio of any term to the previous term is constant. The nth term of a geometric sequence with first term a sub 1 and common ratio r is given by this rule. Tell whether the sequence is geometric. In problem 1, we'll look for that common ratio by dividing two terms in a row. Negative 8 divided by 4 gives us negative 2. Now we should be able to multiply each term in this sequence by negative 2 and get the next term if it is a geometric sequence. 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. Positive 16 times negative 2 is negative 32. So our test holds, and we can say yes, this is a geometric sequence. Let's do it again in problem 2. Let's look for a common ratio by dividing. 9 divided by 3 is 3, and multiplying. 3 times 3 is 9, but 9 times 3 is positive 27. So our test fails, and we have to say no, this is not a geometric sequence. Here we want to write a rule for the nth term of the sequence, then find a sub 8. The nth term, remember, looks like this. A sub n is equal to a sub 1 times r raised to the n minus 1 power. So to write the rule, we need the first term and we need the common ratio. So for this first problem, we'll divide 2 divided by 5 to get a common ratio of 2/5. So a sub n is equal to that first term, 5, times that common ratio of 2/5 raised to the n minus 1 power. Now you can see that this rule is exponential and it's not going to simplify. We want the 8th term of this geometric sequence, so we'll substitute 8 in for n in our rule that we just wrote and simplify. So I've got 5 over 1 times 2/5 raised to the 8 minus 1 power, that's 7th power. So I've got 7 factors of 2 in the top. 1 factor of 5 is going to cancel top and bottom, so I'm going to end up with 6 factors of 5 in the denominator. So in my calculator, I'm getting 2 to the 7th power is 128, and 5 to the 6th power is 15,625. So there's the 8th term of this geometric sequence. In problem 2, we're given the 4th term and the common ratio. We need to find the first term if we're going to write the nth term rule. So we'll use that 4th term of 3. It's equal to the first term, a sub 1, times the common ratio 3 raised to the 4 minus 1 power. So 3 is equal to a sub 1 times, that's 4 minus 1 is 3, so that's 3 cubed or 27. And now dividing both sides by 27 and simplifying, we get a sub 1 is equal to 1/9. So the nth term looks like this. A sub n is equal to the first term of 1/9 times the common ratio of 3 raised to the n minus 1 power. And now if we wanted the 8th term, we just substitute in 8 for n and simplify. In problem 3, we're given the 2nd term and the 6th term of a geometric sequence, so we need to find both the first term and the common ratio. So we'll write a system of equations. Negative 4 is equal to a sub 1 times r raised to the 2 minus 1 power, and negative 1024 is equal to a sub 1 times r raised to the 6 minus 1 power. So cleaning up this system, I have negative 4 is equal to a sub 1 times r raised to the 2 minus 1 is first power, and negative 1024 is equal to a sub 1 times r raised to the 6 minus 1 power, that's the 5th power. So we'll use substitution to solve. In this first equation, I'll solve for a sub 1. It's equal to negative 4 over r, and then substitute into the second equation. So I get negative 1024 is equal to negative 4 over r times r to the 5th over 1. Now you can see that r is going to cancel top and bottom, so I get negative 1024 is equal to negative 4 times r to the 4th, And to get r to the fourth alone, I'll divide both sides by -4. Negative divided by negative is a positive, and 4 goes into 1024 256 times. Now to get just r, we need to undo that power, so we'll take the fourth root of both sides of this equation. We're taking an even root, so we're going to get two solutions, plus or minus, and the fourth root of 256 is 4. So we're looking for two first terms now. A sub 1 is equal to -4 over +4, which is -1. Or we could have another sequence where a sub 1 is equal to -4 over -4, which is +1. So we'll write two nth term rules. A sub n is equal to the first term of -1 times that common ratio of +4 raised to the n minus 1 power, or a sub n could equal a first term of 1, which I don't need to show, times a common ratio of -4 raised to the n minus 1 power. So two possible geometric sequences here, and if I wanted the eighth term for either of those sequences, I could substitute 8 in for n and simplify. One term of a geometric sequence is 54. It's the fifth term. The common ratio is 3. We want to write a rule for the nth term, then graph the first 6 terms of the sequence. So we need the first term. It's not given. We have a common ratio of 3. So to find the first term, we'll use that fifth term of 54. It's equal to the first term times the common ratio of 3 raised to the 5 minus 1 power. So 54 is equal to a sub 1. 5 minus 1 is 4. 3 to the fourth power is 81. And dividing both sides by 81, a sub 1 is equal to 54 over 81. There's a factor of 27 top and bottom. 27 goes into 54 twice and into 81 3 times. So now that we have the first term and the common ratio, we can write a rule for the nth term. It's equal to that first term of 2/3 times that common ratio of 3 raised to the n minus 1 power. We want to graph the first 6 terms in this sequence, so we'll make a table of values and let n equal 1, 2, 3, 4, 5, and 6. And find a sub n. We found a sub 1, it's equal to 2/3. Now we can get each term after that by multiplying by our common ratio. So 2/3 times 3 is 2, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, and 54 times 3 is 162. So now graphing, I'll label these axes. And graph first 1, 2/3, close to the x-axis. 2, 2, we're moving further from the x-axis. 3, 6, a little further. 4, 18. 5, 54. We're taking that sharp turn as an exponential growth curve would. And 6, 162. So you can see that these points do form an exponential growth curve. The expression formed by adding the terms of a geometric sequence is called a geometric series. The sum of the first n terms of a geometric series with common ratio not equal to 1 is given by this formula. So in problem 1, we want to find the sum of the geometric series, and our series is given in sigma notation or summation notation. So the sum of these 6 terms is equal to the first term, which we can find by letting I equal 1. 1 minus 1 is 0. Anything to the 0 power is 1, and 1 times 4 is 4. So we get a first term of 4. Okay, our common ratio is 3/2. It's 3/2 that's raised to the I minus 1 power. So in our formula for the sum, we'll put 3/2 and raise it to the 6th power. That's how many terms we're summing. And in the denominator, 1 minus that common ratio of 3/2. Okay, now we need to simplify, so we have 4 over 1 times a numerator here of 3 to the 6th power, which I'll use my calculator to evaluate. 3 to the 6th power is 729. And 2 to the 6th power I know is 64. So I'm going to write 1 as 64 over 64 so that I can have a common denominator and combine those terms. In the denominator I have 2 halves take away 3 halves, that's negative 1 half. But we don't divide by a fraction, we multiply by its reciprocal instead. So I'm going to invert and multiply. Okay, now I need to simplify inside parentheses, yet I have a difference. I'm going to have more negatives than positives, and I'll get 665 over 64, negative 665 over 64, and so it's a negative times a negative. That's going to give us a positive sum. We can cancel 4, it goes into 64 16 times, and then we can cancel our factor of 2 also, it goes into 16 8 times. So our sum is 665 over 8. In problem 2, we want to find the sum of the first 10 terms of the geometric series that's given. So we'll use our sum formula. We're summing 10 terms. The first term we can see is 4. And our common ratio we'll have to find by dividing. So that common ratio for this geometric sequence is 1 divided by 2. Any 2 terms in a row, remember, will give us that common ratio. And we're summing 10 terms, so n is 10. In the denominator I have 1 minus 1 half. So simplifying, I've got that 4 over 1. In the numerator I've got 1 to the 10th power, that's 1. 2 to the 10th power, that's 1024. So I'm going to write 1 as 1024 over itself. So I have a common denominator again. And then in the denominator it's 2 halves take away 1 half, so that's 1 half. And I'm going to invert and multiply it to the numerator. Okay, so I've got 4 over 1. And in parentheses I have 1023 over 1024. And now I want to get rid of any factors alike, top and bottom. 4 goes into 1024 2, 5, 6 times, 256 times. And 2 goes into 256 128 times. So our sum is 1023 over 128. Include with your notes of this video guided practice problems 2 through 7 on pages 810, 812, and 813 of your textbook.